This is a video that deals with section 6.1. I know it seems odd that we're going from section 5.1 straight into 6.1, but what I'm doing here is merging chapters 5 and 6. Let me know, contact me if you'd like to know more information about why I'm doing that. I won't take the time in the video to deal with that. But chapter 6 is all about radians. Chapter 5 is mostly about angles in degrees. So I want to introduce radians to you. Let's talk first of all very technologically about what a radian is. And so the definition of radian is that it's an angle with its vertex at the center. You'll notice here that I've got an angle at the center on all three of these pictures. The angle is at the center of the circle, and this angle intercepts an arc on the circle equal in length to the radius of the circle. Now, if this happens, then what we're looking at here is that the arc length, so this arc length, if it is the same as this radius, now on the picture that I chose, it isn't, but if the arc length is the same as the length of the radius, then we will say that we have the measure of that angle is 1 radian. The measure of that angle is 1 radian. You'll see here that I've got 3 different options, 3 different examples. That first example, my central angle is 2 radians because that arc is 2 radii put together. It's the same as 2 radii. The second one, my arc length is only half of a radius. And that third one, notice that I'm going all the way around the circle. My central angle is the equivalent. It's not just the distance around, but we call that circumference. So I'm going all the way around the circle. And you notice that it tells you that that central angle, its measure is 2 pi radians. We'll discuss that here in just a moment. So this is where the technological discussion comes in. So hang with me. You might need to watch this a couple times to get an idea of exactly what it's talking about. In general, if theta is a central angle of radius r and theta intercepts an arc of length s, then the radian measure of my angle, that central angle, is going to be s divided by r. Now let's talk about exactly what we're talking about here. The arc length we're calling s. The theta, that central angle, we're calling r. Theta. And my radius we're calling r. Okay, so the arc length is s. The radius is r. The central angle we're naming theta. Let's keep reading. If the circumference of a circle, now revisit high school geometry. What was the circumference of a circle? Well, the formula for circumference of a circle is 2 pi r. So if the circumference of a circle is found by 2 pi r, then the radian measure, that angle measure of a whole entire circle, is going to be circumference is equal to, all right, let's use this guy here, S, the whole entire arc length. Well, the whole entire arc length is going to be 2 pi r divided by, again, using this formula, divided by r. So 2 pi r divided by r, your r's will cancel, leaving you only with 2 times pi. Just a side note here, the ratio S over R, this is a pure number. S and R are both expressed in the same units. They're expressed in a distance. So radians then, because that same unit is going to cancel out, radians is not a unit of measure. It's not like feet or centimeters or anything like that. All right, so think about the discussion that we had in section 5.1 dealing with going around the whole entire circle. We know that that's 360 degrees. Well, now we also know, according to the discussion that we just had, a whole entire circumference in radians is going to be 2 pi. So 360 degrees is the same thing as 2 pi radians. If you took that little true statement, equal statement, and you divided by 2 on both sides, you would get 180 degrees is equal to pi radians. Now I want you to pause the video after I ask you this next question, and I want you to answer this question. What has to be true about some fraction if this fraction's value is equal to 1? What is true about every fraction whose value is equal to 1? Pause the video and answer that question. Well, if you're back now, hopefully you said that if a fraction equals 1, the top and the bottom both have to be equal measures or equal numbers. And so what we would say then is that we can set up 2 fractions that are equal to 1. One of them is that 180 degrees divided by pi radians, since the top and the bottom are equal to each other, according to what we just said, then this fraction is equal to 1. Not only that, I can reverse the order and say pi radians over 180 degrees is equal to 1. So then what I'll do is, if I want to convert from degrees to radians or radians to degrees, if I have a degree measure, all I'm going to do is simply multiply my degree by pi over 180. If I have a radian measure, I'm going to take my radian measure and multiply by 180 over pi. So let's put this into practice. We have 3 different examples of degrees, and so we want to convert to radians. Well, so what I want to do here first is to multiply by pi over 180. The deal here, the way that you can remember this easily, is you notice that the degree on top and the degree on bottom are 2 units that you want to cancel out. And so the only unit that's going to be remaining is going to be the radian unit that goes along with that pi. So that's why this conversion works. If you put this into your calculator, I would say the directions don't tell us this, but they are going to be specific. Sometimes it's going to say leave as a multiple of pi. So if it says to leave as a multiple of pi, you need to leave pi in your answer, and the rest of it just simply needs to be reduced. So 108 over 180 is going to be 3/5, and I'm leaving pi in my answer, so 3 pi over 5 is the same thing. 3 pi over 5 radians is the same thing as 108 degrees. For part B, same thing. If I want to change negative 135 degrees into radians, I'm going to multiply by pi over 180. I'll reduce my fraction, and I'll get negative 3 pi over 4. You might say, you keep writing degrees, but you don't write radians. And I'll discuss that here in just a moment. That is on purpose. That is intentional. Now, this next one is a little bit uglier, 325.7 degrees. But once again, we're going to multiply by pi over 180. If you're told to leave as a multiple of pi, what I would do, instead of reducing this fraction, because you don't want to leave decimals and fractions in the same answer, instead of reducing, I would just go ahead and get a decimal answer for that. And so if I leave as a multiple of pi, that would be 1.809 pi radians. If I choose to multiply by pi, if it doesn't tell me to leave as a multiple of pi, then I would go ahead and multiply by pi, and that would be 5.685. Now let's go backwards. Each of the following are radians. And you say, well, they don't have radians. How do you know they're radians? And I'm going to discuss that in the box down below. But for now, just trust me, these are radians. So if I have 11 pi over 12 radians, the first thing I'm going to do is multiply by 180 over pi. You say, oh, I know how to do that because the reason I chose 180 over pi is because I want to cancel the pi's. Now, granted, the pi's are going to cancel, but that's not why you're choosing 180 over pi. You're choosing 180 over pi because technically there's a radian on top and there's a radian on bottom. There's a degree on top. You want your radians to cancel, leaving you only the degree unit. So that's really why you're choosing 180 over pi. So just get that into your mind. But you are correct. The pi's are going to cancel as well as the radians. There's more that you can cancel. There's more reducing that you can do. The calculator can do this for you, but if I reduce everything, I'm going to get 330 degrees. For negative 7 pi over 6, let's go ahead and multiply by 180 over pi. Yes, the pi's will cancel. Do the math and you'll get negative 210 degrees. Letter C is a radian, so negative 2.92 radians. We're going to do the same thing. We're going to multiply by 180 over pi. And again, my radians are canceling. So that's what I want to cancel here, leaving me with just degrees. So this is one that I'll plug into the calculator. And so if I plug in negative 2.92 times 180 divided by pi, I'll get negative 167.3. You may want to turn this into degrees and minutes, or degrees, minutes, and seconds, depending on what the directions say. And you know how to do that conversion on your calculator according to what we learned in section 5.1. All right, now let's talk about those units, because I keep leaving off the units of radians, but I try to write the degree symbol when it's a degree. Here's the deal. If no angle measure is specified, it's automatically a radian. The lack of a degree symbol says it's a radian. So you'll see two examples here. One of them is a picture of 30 degrees, and the other one is a picture of 30 radians. You can see that these are totally different angle measures. They don't even land in the same quadrant. But 30 radians would just simply be written as an angle of 30, or just simply 30. Maybe it would say theta equals 30, and that would automatically mean 30 radians. So just understand that these are very, very different from each other. This next block here, I'm going to just let you fill this in at your leisure. This would be something that I would do before you start working on any assignments.